But for the block maps, it's totally flat. So if it's totally flat, you can partition that more easily than partition the tree structure, so that you can have different ways to solve that problem. And there is a crush, a paper called Crush, which is also in the Ceph. Ceph is a philosopher from, you see, Santa Cruz, right? And they have some interesting algorithm there by saying like how we are going to assign different blocks to different places, and you can still find it. Yeah, that's. But right now, I don't have a solution or a prototype for the solution yet.
Okay, last question.
So you mentioned that you got rid of the edit logs, right? So suppose we're in a situation where we're trying to recover a name node, and all we have is this disk-based DB implementation that you have with key values and values mapped to inodes. The in-memory representation, do you have a heuristic on how you populate in case of a recovery, or you just leave it empty and as and when requests come in, it gets populated?
So right now, when there is a failure, I think my understanding for the question is whenever there's a failure, how do we do recovery? Is that correct? So whenever there's a failure, because we always try to store our namespace in this, the question comes down to how the recovery is done by the underlying key value store. And in this case, that will be the level T. So the system itself has cache of inodes, but the cache is, you can always work without cache, it's just the performance will be worse. That's it.
Let me clarify. There is you're worried about the data being lost completely?
Let's say you said you lose your system and you lost your edit logs. So level DB has its own wall. You don't risk any loss of data. It's just that it pages things in as needed. Okay, and you could say I'll wait till it pages in more before it starts. That's the top part of it. So it starts a little bit slower, but then remember the namespace waits for you to page everything in. So you will see that there really isn't a lag. And as far as safety, it is equally safe. Everything is equally persistent.
Oh, and also thanks to Rob and CJ from the game helping to run my program there. And thank you guys for listening, and hope to get feedback from you or running my program in your place. I'm not going to expose any sensitive information, I guarantee that. Let's try to study what the workload will be like so we can have better benchmarks.